Good morning, good afternoon, everyone, and thank you for being here watching my video on YouTube on my channel. Today, I am going to talk about Docker. Now, some of you in this session write code every day, and some of you have never opened a terminal, and that is completely fine. This session is built for both. I promise to keep the jargon low and the analogies high. Here is the one idea I want you to live with, and it is right there on the screen. Docker lets us ship software the way the world ships physical cargo. You pack it once and it runs anywhere. By the end of these 10 slides that I will cover in this session, that sentence is going to make complete sense for you guys. So let us get into it. What is Docker? So let us answer the obvious question first. What actually is Docker? Here is the definition in one sentence, and it is most important sentence on this slide. Docker is a tool that packages an application and everything it needs to run in a single portable unit, which is called a container. Let me unpack that, because the key phrase is everything it needs to run. An application on its own is rarely enough. It needs settings, it needs supporting libraries, it needs a particular version of this and that. Docker takes the app and all of that supporting baggage and seals it into one box, which is called the container. And once it is in that box, three things become true. As you can see on the right on this slide, the first thing is everything travels together, so nothing gets left behind. Number two, it runs the same way everywhere. It doesn't matter where you are, it should run the same way everywhere. Okay, so that means that the famous phrase like, well, it works on my computer, simply stops happening. And number three is it is lightweight and fast. A container starts in seconds, not in minutes. Hold on to that word container. It is the heart of everything we will talk about today. Why was Docker created? Well, every tool is born to solve a pain. So let us look at the pain Docker was created to solve. Picture the world before Docker. The left side of this slide basically is picture of the world before Docker, right? The old problem. A developer builds something on their laptop, it works perfectly on their local machines, they hand it to a teammate or they move it to a server, and then suddenly it breaks. Why? Because that other machine is set up just slightly differently. Every developer, they set up their machine based on their requirements, based on their preferences. Not every machine is operating the same way. So that is the infamous it works on my machine problem, and it cost teams an enormous amount of time, right? On top of that, setting up a server means hours of manual configuration. Different tools fought with each other over versions, over different versions or version control. And moving an application anywhere felt risky because you never quite sure if it would survive the trip. Then in 2013, Docker arrived with the simple answer, the right side of the slide. Instead of hoping every machine matches, pack the application and its whole environment into one container, build it once, and it runs identically everywhere. Each app stays in its own sealed box, so versions never collide with each other. and setup drops from hours of guesswork down to seconds. Docker did not invent a fancy new idea. It took an old, painful problem and made the solution easy enough that everyone could use it. Okay? A simple analogy, shipping containers, right? If you think that way. This is my favorite slide, by the way, because this analogy is where Docker really clicks, especially if you have never touched code. Think about how cargo moved around the world before the 1950s. Every item, whether barrels, sacks, boxes of all shapes, was loaded onto ships loose by hand. It was very slow process, it was messy and lot of stuff got damaged or lot of stuff got lost. Then someone introduced the standard steel shipping container. One agreed size, and it transformed global trade because now it does not matter what is inside the box. Any container fits any ship, any crane, any truck. The thing carrying it never needs to know what is inside. Docker, by the way, does exactly this, but for software. Look at the three cards. The shipping container itself. The standard box handles the same way every time. It is a Docker container. The ship or the truck that carries any box without caring about its contents. That is any computer or server your software runs on. And the point that smoothly loads, stacks, and tracks thousands of containers, that is Docker itself and the tools around it. So whenever I say container for the rest of this session, just picture that steel box on a ship. Same idea, nothing different. We just standardized the box for software. Okay? Moving on to the next slide. How Docker works. You might be wondering how Docker works. Well, now that we have the picture, let us peek under the hood gently. Docker turns your code into a running container using just three building blocks. First, the Docker file. Think of it as a recipe. It is a simple text file that lists the steps and ingredients needed to build your application. Nothing more intimidating than a cooking recipe written down. Second, the image. When you follow that recipe, you get an image. The image is the blueprint, a read-only frozen snapshot of your fully built application. Because it is frozen, you can copy it, share it, and reuse it, and it stays exactly the same. Third, the container. When you take the blueprint and actually start it up, you get a container. The container is the live running copy. That is your application actually working and doing its job. So the flow is basically you have recipe to blueprint to running app, right? Docker file, image, container. And tying it all together along the bottom is the Docker engine. It runs quietly in the background, it builds the images, and it starts, stops, and manages the containers. One more important detail is all those containers share the host's computer's operating system. Keep that point in your back pocket. It is exactly why containers are so light, and it is the key to the very next slide. Virtual machines versus Dockers. Some of you may be thinking, in the technology world, have not we been able to run software in isolated environments for years with virtual machines? Good question, by the way. So let us put them side by side. A virtual machine on the left is a full computer simulated inside in your computer. And because it is a whole computer, it carries its own complete operating system. That makes it heavy, often several gigabytes, and slow to start, frequently a matter of minutes. it does give strong isolation, but you pay for it in resources. A Docker container on the right is different. It does not carry its own operating system. Instead, it shares the one already on the host machine. So it only contains your app and its dependencies, nothing extra. That makes it lightweight, typically megabytes, not gigabytes, and it starts in seconds. And because each one is so efficient, you can run many containers on a single machine. Here is the bottom line, and it is one sentence to remember from this slide: a virtual machine uh, virtualizes an entire machine, while Docker virtualizes only the application. That is the whole difference. That is why Docker is so much lighter and faster. And to be clear, this is not Docker is good, virtual machines are bad. They solve different problems and they are often used together. Docker is a simply the lighter, faster choice um, when what you want is to ship an application. I hope that makes sense to you guys. Now let's talk about what Docker specializes in. So we know what Docker is and how it works. Let us now name what it is genuinely great at. Its core strengths. There are six strengths. I will move slowly through them. Consistency. Your software behaves identically from a developer's laptop through testing all the way to production. No surprises in the transit. Isolation. Each container is a self-contained, so one application can never interfere with other application. So they are good neighbors. Speed and efficiency. Containers start in seconds and you can pack many of them onto a single machine. Portability. The very same container moves freely between laptops, data centers, and any cloud provider. Scalability. When demand rises, you can spin up many identical copies almost instantly. We will see why that matters on the next slide. And reproducibility, because images are versioned, right? You can rebuild the exact same setup perfectly every single time. If you notice a theme across all those six is predictability, right? You have understood Docker. It removes the guesswork from running software, right? Now let's talk about what you can achieve with Docker. Well, strengths are nice in the abstract, but what they do actually let a team do, right? Let us make it concrete. Look at the three numbers on the left. Seconds. It that is how fast an application starts instead of minutes or hours. Once you build it in, once you build it a single time, then run it anywhere. And zero, that is how many it works on my machine. Excuses are left. On the right are the real world wins. Teams ship faster, moving new features into people's hands with confidence. New team members onboard in minutes. They run the entire project with a single command instead of losing their first day to set up. Big big applications can be broken into small independent containers. That is the microservices idea. That is called microservices. Docker powers automated testing and deployment, the continuous integration, continuous deployment, CI CD pipelines. Many of you heard of it. And it cuts cloud costs, right? Because you can pack more work into fewer machines. So Docker is not just a convenience for developers, it changes how the entire team and honestly the entire business delivers the software. Now let's talk about the common Docker workflow. Um, you know, walk through what actually using Docker look like day to day. It is a simple 5 step cycle. Step 1, write. You create the Docker file, that recipe we talk about describing how your application should be built. Step 2 is build. You run one command, Docker build, and Docker follows the recipe to produce an image. Step 3 is run. You run Docker You run docker run and the image starts up as a live container. Your application is now working. Step 4, share. You push that image to a registry, a shared library for images, the best known being Docker Hub, so other people and other machines can get it. Step 5, deploy. Anywhere else, a test server, a production server, the cloud. You simply just pull that same image and run it anywhere, right? Now, here is the key idea in the band, at the bottom, and it is the payoff of the whole session. The image you built and tested is exactly same image that runs in production. Nothing is rebuilt, nothing is reconfigured, nothing changes along the way. That is what makes Docker so dependable, right? Why learn Dockers? Now, in wrap up and in closing, we are at the last slide. So let us bring it home with a simple question. Why is it worth your time to learn Docker? There are four reasons. First, it is now an essential skill. Docker is a standard across software, data, or cloud roles, and so it is genuinely worth knowing. Second, it gives everyone a shared language. Developers and operations team finally have one common way of working, which means fewer misunderstandings, right? And the third reason is it is a future ready. Docker is the foundation underneath cloud computing, microservices, modern AI platforms. And number four, it is genuinely easy to start. It is free of cost, it is well documented, and you can pick up the basics in a single afternoon. So let me close where we began. Docker lets us pack software once and run it anywhere. The same idea that the humble steel shipping container brought to global trade. Pack it once, run it anywhere. Thank you all of your time and attention. I would genuinely love your questions, and if you would like, I'm happy to show a quick live demo in my next video session, because I wanted to make this video very brief. And I try to make this session simple enough that a non technical guy, non IT guy can understand about Docker, why it is used, why it is important. In my next session, I will show the live demo, right? um, Let me show you real quick. So this is the, if you search on Google Docker, and this is the landing page, and this is all about Docker. This is the official website, and you can install it. You can download the Docker desktop version based on your machine. If you have a Mac operating system, depending on your processor, if it is a Apple Silicon, you can download that version. But if you have older Mac operating system or machine using Intel chip, you can download that version. If you're using Windows, you can download that version, AMD 64. If you have a ARM 64, you can download that. For Linux, this is the link. And in fact, I was even though I had a Docker installed previously on my machine, I deleted it and I downloaded it again, right? So this is the file I downloaded. So I move this Docker to the right side, to the applications, right? And it's a pretty large size, 2.43 gigabyte. It take up that space, right? It takes this fraction of seconds to download it. And if I go to my applications and see, Docker is installed there. Okay, a couple of verifications. I want to open it. My system is asking me, just for safety reason, yes, I want to open it. And software upgrade is required. Okay, I want to accept it, right? And actually my software update, my machine has a older software version, and it got a new update. First I have to install that. So in my next video session, I will explain step by step how to download Dockers. Um, Thank you for your time. I appreciate.